Hello learners, welcome to the course Statistical Methods for Economics Module 5. In this session, we will discuss the concepts related to partition values, understand the importance of partition values in economics, computation of the partition values for different data types, identify the situation where partition values are more suitable, locating the partition values graphically. In Module 4, we had discussed about the concept of averages. The various types of averages we have seen, how the arithmetic mean can be computed for ungrouped and grouped data. Also, the mathematical properties, merits and demerits of arithmetic mean were discussed. As a continuation, in this module, we shall discuss the next measure of central tendency, that is partition values. Partition values are the statistical measures which are used to divide the observations from distribution to equal parts. The various measures of partition values are median, quartiles, deciles and percentiles. We shall now look into the application of partition values. Partition values are used to study the financial information concerning to economics, income, stocks, sales and survey. Comparing the changes among the individual income group caused by economic changes such as wage fluctuations and inflation can be done with quartiles. The application of deciles can be seen in the studies related to level of economic inequality, measurement of poverty line, drought conditions, etc., which are taken up by government or agencies. Deciles are used to assess the performance of a portfolio investment such as a group of mutual funds. In order to measure the test scores, health indicators, household income, percentiles are helpful. Percentiles can be used for benchmarking the baseline purposes. Median. Median is the middlemost or the central value of the variable in a set of observations when observations are arranged either in ascending or in descending order of magnitudes. Median is the value of that item in a series which divides the series into two equal parts. One part consisting of all the values less and the other all values greater than it. Median is also called as positional average. Now, we shall see how to compute median for ungrouped data. First, arrange the data in ascending order of magnitude. Then, if the number of observations is either even or odd, then median is computed using the formula median is equal to n plus 1 divided by 2th value. Now let us see how to compute median for grouped data. First, let us look into the steps involved in the computation of median for discrete data. As the first step, the data should be in ascending order of magnitude. Then, prepare the less than cumulative frequency distribution. After that, find the n by 2th value. Now, see the cumulative frequency just greater than n by 2th value. The corresponding value of the variable gives the median value. Now let us see how to compute median for continuous series. First, arrange the data in ascending order of magnitude. Then, prepare the less than cumulative frequency. After that, find the n by 2th value. Now, see the cumulative frequency just greater than n by 2th value. The corresponding class contains the median value and it is called the median class. Once the median class is identified, the median is obtained using the interpolation formula given by median is equal to L plus H by F into N by 2 minus C, where L is the lower limit of the median class, F is the frequency of the median class, H is the width of the median class, N is the total frequency, C is the cumulative frequency of the class preceding the median class. In the computation of median, it is important to note that the distribution of the variables under consideration is continuous with exclusive type class interval, and there should be an orderly and even distribution of observations within each class. Let us see how median can be obtained graphically. The following are the steps involved in obtaining the median through graph. First, plot the less than cumulative frequency against the corresponding value of the variable. That is, draw a less than ogive. Then, at the frequency of n by 2th value along the y-axis, draw a parallel line to x-axis meeting the ogive at the point P. The point in the x-axis is the median value. Now, let us look into certain merits of median. It is rigidly defined. It is easy to understand and easy to calculate for a non-mathematical person. It is not influenced or affected by the variation in the magnitude of the extreme values. It can be computed while dealing with a distribution with open-end classes. Value of median can be located graphically. Median can be determined even by inspection in many cases. It is the best measure for qualitative data. Let us look into the demerits of median. For the calculation of median, data must be arranged in order. Median being a positional average, it is not based on each and every item of the distribution. Median is not suitable for further mathematical treatment. Median is relatively less stable than arithmetic mean. Let us look into the practical examples to compute median. Compute the median for the following data: 28, 24, 29, 22, 21, 37, 20, 31. Now, to compute median, first arrange the data in ascending order. So, arranging the data in ascending order, we have the observations as 20, 21, 22, 24, 25, 28, 29, 31, 37. The number of observations, that is n, is equal to 9. Median is n plus 1 by 2th item. Here n is equal to 9. So we have 9 plus 1 by 2th item. It is 10 by 2th item, that is 5th item. Now in the arranged data, look into the 5th item value, that is 25. Hence the median of the given data is 25. Let us consider another example for computing median. Compute the median for the following data: 20, 21, 26, 23, 19, 19, 25, 22. Now, to compute median, first arrange data in ascending order. So, arranging the data in ascending order, we have the observations as 19, 19, 20, 21, 22, 23, 25, 28. The number of observations, that is n, is equal to 8. Median is n plus 1 by 2th item. Here n is equal to 8. So we have 8 plus 1 by 2th item. It is 9 by 2th item, that is 4.5th item. Now 4.5th item is computed as 4th item plus 0.5 into 5th item minus 4th item. Looking for the values in the ordered data, we have 4th item is 21. 5th item is 22. Hence, substituting it, that is 21 plus 0.5 into 22 minus 21. On simplification, the value is 21.5. The median of the given data is 21.5. Now, let us compute median for the discrete data. Consider the following frequency distribution for computing the median. Arrange the data in the tabular form. In the first column, consider the x values, and in the second column, consider the frequency values. The less than cumulative frequency values are 13, 28, 44, 62, 78, 93, 106, which is noted in column 3. The median is given by n by 2th item. So, we have 106 by 2th item, which is 53rd item. In the less than cumulative frequency, check for the value greater than or equal to 53. We see that it is 62. The x value corresponding to 62 is 25. Hence, the median of the given data is 25. Now, let us see how to compute median for a continuous data. The profit earned by 100 companies is given below. Compute the median profit earned by the companies. To compute the median, let us first tabulate the data. Consider the profit given as class intervals in the first column and the number of companies denoted by F in the second column. The less than cumulative frequency values are 7, 15, 25, 40, 70, 88, 96 and 100, which is noted in the third column. For the identification of the median class, first compute n by 2th item, that is 100 by 2th item, which is 50th item. In the less than cumulative frequency, check for the class greater than or equal to 50. We see that it is 70. Hence, the median class is 60 to 70. Now, apply the median formula L plus H by F into N by 2 minus C to compute median, where L is the lower limit of the median class, which is equal to 60. F is the frequency of the median class, which is equal to 30. H is the width of the median class, which is equal to 10. N is the total frequency, which is 100, and C is the cumulative frequency preceding the median class, which is equal to 40. Now, substituting these values in the formula, we have median is equal to 60 plus 10 by 30 into 100 by 2 minus 40, which is equal to 60 plus 1 by 3 into 50 minus 40, which is equal to 60 plus 1 by 3 into 10, which is equal to 60 plus 3.33. That is equal to 63.33. Hence, the median profit earned by the companies is 63.33 lakhs. Quartiles. The value of data which divide the distribution into 4 equal parts are known as quartiles. There are 3 points which divide the data into 4 equal parts. They are Q1, Q2, Q3. The first or lower quartile Q1 covers 25% of the data points. The second or middle quartile Q2 covers 50% of the data points. And the third or upper quartile Q3 covers 75% of the data points. In general, the quartiles are denoted by QR, where R is equal to 1, 2, 3. Now, we shall see how to compute quartiles for ungrouped data. First, arrange the data in ascending order of magnitude. Then, if the number of observations is either even or odd, then quartile is computed using the formula quartile is equal to R into n plus 1 divided by 4th value. Now let us see how to compute quartile for grouped data. First, let us look into the steps involved in the computation of quartiles for discrete data. As the first step, the data should be in ascending order of magnitude. Then, prepare the less than cumulative frequency distribution. After that, find the R into n by 4th value. Now, see the cumulative frequency just greater than R into n by 4th value. The corresponding value of the variable gives the quartile value. Now, let us see how to compute quartiles for continuous series. First, arrange the data in ascending order of magnitude. Then, prepare the less than cumulative frequency. After that, find the R into n by 4th value. Now, see the cumulative frequency just greater than R into n by 4th value. The corresponding class contains the quartile value and it is called as the quartile class. Once the quartile class is identified, the quartile is obtained using the interpolation formula given by quartile is equal to L plus H by F into Rn by 4 minus C, where L is the lower limit of the quartile class, F is the frequency of the quartile class, H is the width of the quartile class, N is the total frequency, C is the cumulative frequency of the class preceding the quartile class. Deciles. The values of data which divide the distribution into 10 equal parts are known as deciles. There are 9 points which divide the data into 10 equal parts. They are D1, D2, D3, etc. D9. Each part consisting of 10% of the total observations. In general, the deciles are indicated by dr, r is equal to 1, 2, etc. 9. Now, we shall see how to compute deciles for ungrouped data. First, arrange the data in ascending order of magnitude. Then, if the number of observations is either even or odd, the deciles is computed using the formula deciles is equal to r into n plus 1 divided by 10th value. Now, let us see how to compute deciles for grouped data. First, let us look into the steps involved in computation of deciles for discrete data. As the first step, the data should be in ascending order of magnitude. Then, prepare the less than cumulative frequency distribution. After that, find the r into n by 10th value. Now see the cumulative frequency just greater than r into n by 10th value. The corresponding value of the variable gives the decile value. Now let us see how to compute deciles for continuous series. First, arrange the data in ascending order of magnitude. Then prepare the less than cumulative frequency. After that, find the r into n by 10th value. Now see the cumulative frequency just greater than r into n by 10th value. The corresponding class contains the decile value and it is called as the decile class. Once the decile class is identified, the deciles is obtained using the interpolation formula given by deciles is equal to L plus h by f into Rn by 10 minus c, where L is the lower limit of the decile class, f is the frequency of the decile class, h is the width of the decile class, n is the total frequency, c is the cumulative frequency of the class preceding the decile class. Percentiles. The value of data which divide the distribution into 100 equal parts are known as percentiles. There are 99 points which divide the data into 100 equal parts. They are P1, P2, P3, etc. P99. Each part consisting of 1% of the total observations. In general, the percentiles are indicated by PR. R is equal to 1, 2, etc. 99. Now, we shall see how to compute percentiles for ungrouped data. First, arrange the data in ascending order of magnitude. Then, if the number of observations is either even or odd, then percentile is computed using the formula percentiles is equal to r into n plus 1 divided by 100th value. Now, let us see how to compute percentiles for grouped data. First, let us look into the steps involved in the computation of percentiles for discrete data. As the first step, the data should be in ascending order of magnitude. Then, prepare the less than cumulative frequency distribution. After that, find r into n by 100th value. Now, see the cumulative frequency just greater than r into n by 100th value. The corresponding value of the variable gives the percentile value. Now let us see how to compute percentiles for continuous series. First, arrange the data in ascending order of magnitude. Then prepare the less than cumulative frequency. After that, find the r into n by 100th value. Now see the cumulative frequency just greater than r into n by 100th value. The corresponding class contains the percentile value and it is called the percentile class. Once the percentile class is identified, the percentiles is obtained by using the interpolation formula given by percentiles is equal to L plus h by f into Rn by 100 minus c, where L is the lower limit of the percentile class, f is the frequency of the percentile class, h is the width of the percentile class, n is the total frequency, c is the cumulative frequency of the class preceding the percentile class. In the similar lines of computation of median, all the partition values can be computed. Summarization. In this session, we have discussed about the concept of partition values. The various partition values discussed are median, which divides the distribution into two equal parts, quartiles which divide the distribution into 4 equal parts, deciles which divide the distribution into 10 equal parts, and percentiles which divide the distribution into 100 equal parts. Thank you.